Assalamualaikum and good day. Today we are going to present about the group assignment, and so this is our group members, and next my team member will present on the introduction.
My name is Irfan and my metric is 309201021. So for the introduction, electric vehicles EVs use suspension system similar to traditional cars, crucial for stability and passenger comfort. Some EVs employ the electric vehicle EV strut suspension, known for its simplicity and integration with the hub carrier, enhancing steering geometry. This design contributes to stability, often featuring a coil spring for a smoother ride. Compared to alternatives like double wishbone builds, EV struts offer simplicity and are favored in EVs, especially those with unibody structures, due to their efficient design and performance characteristics.
The literature review consists of three different technologies that have been used. The first one is the robust vibration control. It uses a unified mu synthesis framework for robust vibration control in a wheel motor driven electric vehicles. The mu synthesis feedback controller provides less conservative stability and better performance margins compared to the H infinity method. Simulation results demonstrate effective reduction of negative vibration. The second technology is the energy regenerative suspension system. It explores conventional hydraulic energy supply suspension and their transformation into energy regenerative system for improved efficiency. The energy regenerative suspension can recover about 50% of the energy efficiency. Various recovery methods and their impact on factors like fuel consumption and energy recovery are discussed. The third one is the regenerative active suspension system. It proposes a regenerative active suspension system with a dynamic damper mechanism and in-wheel motor for improved vehicle comfort and safety. The system achieved 52% improvement in ride comfort and a 14% enhancement in comprehensive performance. A variable threshold strategy for the hybrid energy storage system enhances regenerative efficiency. Okay, the difference between the three technology is each study address different aspect of suspension system. The first one focus on robust vibration control, the second one explores an energy regenerative suspension, and the third one introduce a regenerative active suspension system. The first one use mu synthesis, the second one review hydraulic energy regenerative suspension, and the third one propose a new regenerative active suspension system. The benefit is the first one approach improve stability with less conservation. The second one discuss energy efficiency and recovery method, and the third one achieve significant improvement in ride comfort and comprehensive performance. And the challenge that they face, that the first one and the second one do not explicitly mention unsolved challenge, while the third one highlight challenge in the development of energy regenerative suspension.
Assalamualaikum and good day. I'm Irfan Danial. Today I'm going to explain about the task B, the comparison between suspension types in electric vehicles. So the first one is BYD Dolphin, which is a segment A car, and for the front suspension it uses McPherson struts for cost effectiveness, space efficiency and responsive handling. For the rear suspension, it uses torsion beam, and it is chosen since it gives ride comfort and handling, and it is simple and cost effectiveness in manufacturing smaller vehicles in this segment. So for the tire profile, it uses 195/60 with 16-inch rims. It is chosen for optimization of performance, ride comfort and stability and handling, and it is also cost efficiencies for segment A cars. It reduces manufacturing costs and potentially benefits the customers. So the second one is Tesla Model 3, which is a segment B car, and this is a high-end electric vehicles, and it uses double wishbone on the front since it enhances handling, steering response, stability during cornering. And for the rear suspension, it uses the multi-link with coil spring, and it improves traction during acceleration and reduces body roll. And since it is a rear-wheel drive car, the traction is very important. And the tire size and rim size, it uses 18-inch rim with 235 45 tire profiles, and larger rims, it will enhance the handling and responsiveness during the cornering. And for the last one is Hyundai Kona Electric, which is a segment C car. It uses a McPherson strut for the front suspension because it is efficient, cost effective, and it gives responsive handling for a front wheel drive configurations. So for the rear suspension, it uses the independent multi-link suspension, and because it enhances the handling, stability, ride comfort, and it provides a balance between a cost efficiency, manufacturing consideration, and also the suspension choices meet the safety and regulatory standards for C-segment EV in Hyundai Kona Electric. So for the rim size and tire profile for this Hyundai Kona Electric, it is equipped with 17-inch rims with 215/45 and 55 tire profiles because it balances strike between handling, performance, and ride quality. And it is also energy efficiency, since it uses 17-inch rims, smaller than the Tesla Model 3, and it also cost effective in manufacturing and easy to maintain.
So today I'm going to explain the task C, which the task will require us to suggest new type of advanced suspension for Formula EV 2024 based on the analysis that we have done. The adaptive, which an active electromagnetic suspension system were envisioned for the Formula EV 2024. Why we chose? Because it has special characteristic that I'm going to explain in this slide. The first special characteristic is it has an electromagnetic mechanical dampers. Electromagnetic mechanical dampers control the flow of the suspension fluid, oil, and manage mechanical motion by adjusting oil flow through holes on the damper body by utilizing a coil and magnet to dissipate kinetic energy and enhance stability in application like automotive suspension. Some systems employ adaptive control with sensors to detect parameters such as vehicle speed, enabling real-time adjustment for optimal performance and ride comfort, particularly beneficial for application like Formula EV. So the second special characteristic is it has magnetic damper fluid, or we can call magnetorheological MR fluid. Magnetorheological suspension system using suspension fluid which contain iron particles, which is a ferrum, which is capable of responding to an electromagnetic field. When the fluid was subjected to a magnetic field, the fluid will greatly increase its apparent viscosity to a point, becoming a viscoelastic solid, which the yield stress of the fluid when it is active. Active is mean by exposed to electromagnetic current. It can be controlled precisely by varying the magnetic field intensity in each of the monotube dampers. Its real-time adjustment of viscosity through electromagnetic fields offer dynamic adaptability to driving conditions. It is also integrated with sensors, magnetite optimized suspension response by varying electromagnetic field intensity. This technology allows driver to select different modes for a balance between comfort and performance based on factors like speed and steering input.
My name is Najiha, so I will conclude the whole conclusion for this study. This study explores the vital role of electric vehicle suspension systems in ensuring stability and passenger comfort. Examining recent advancement and specific EV segments, it emphasizes the delicate balance between cost effectiveness and performance. The proposal for the Formula Electric Vehicle 2024 introduced an adaptive electromagnetic suspension system, addressing limitation of passive suspensions and aligning with sustainability trends. The shift from passive to adaptive electromagnetic suspension system incorporating real-time adjustment and AI-driven predictive maintenance not only address deficiencies in high-speed racing but also embrace regenerative braking and sustainability. This innovative system with electromagnetic, mechanical dampers and magnetoride damper fluid symbolize groundbreaking advancement in electric motorsport. The research contributes a holistic understanding of EV suspension systems, connecting literature insights, segments, specific application, and a forward-thinking proposal, highlighting a pivotal role of suspension in shaping the future of electric mobility. That's all for us. Thank you.